Hello guys, I'm Shubham Gupta. So today's webinar will be on the topic machine learning with Python. So I'm going to start with some basic libraries that are required for implementing machine learning in Python, like NumPys and Pandas, etc. And then I'll move on and show you how various models in machine learning are implemented. So for this, you'll need to have the Conda package installed in your system, and you'll also need to install the libraries required like NumPy, Pandas, etc. And for this, I'm going to use Jupyter Notebook. You can also use any other IDE if you want. So I'll start with NumPys. NumPys are basically linear algebra library for Python. And the reason that they're so important is that almost all of the features in PyData rely on NumPy as one of their main building blocks. So in NumPys, I'll show you arrays. So NumPy arrays are basically uh, they can be either vectors or matrices. Vectors are strictly one-dimensional arrays, and matrices are two-dimensional arrays. And so basically, array uh, it's sort of like a list, but then it can hold only numerical value, and it can be two-dimensional as well. So I'll show you how to create a array. So suppose you have a list lst equal to say 1, 2, 3, 4, and you just need to give n. First I'll import numpy as np. You can give any other name if you want. I've given np. So now I can access numpy using np short form. So I'll just give np dot array of lst, and this list will get converted into an array, numpy array. I can also make it a 2D array if I change the. So if I give it like this and I give some more values, suppose 5, 6, 7, 8. So it becomes a 2 cross 1 array. It becomes a 2 cross 1 array. There are various built-in methods that can be used to generate arrays, and we also have various functions to work on arrays. So I'll first tell you the functions that are used to generate arrays. So there's a function np.arange. Suppose I give 0, 5. So what this will do is this will give me an array having values 0 to 4. So it's basically 1 minus the high value that we specify. If I give suppose np dot arange 0, 12, 3, then this will give me values between 0 to 12, 12 not inclusive, with 3 space, with spaced even, so basically with 3 increments, so 0, 3, 6, 9, and 12 will never be included. So if you want a array of zeros and 1, you can just give np dot zeros. Suppose I want 5. So this will give me an array of 5 zeros, and similarly I can just give np.ones 5. So if I give np.ones 5, it will give me an array of 5 ones. If I want suppose a 5 cross 2 matrix, a 5 cross 2 array of 1, so I'll just give 5 comma 2 and I'll get a 5 cross 2 matrix. Similarly I can give np.zeros 5 comma 2, I'll get a matrix of dimensions 5 cross 2 with all zeros. If I want to create a identity matrix, I'll just give np.I of 5. So it will give me a 5 cross 5 identity matrix. Now linspace is a function. So if I'll give you an example, np.linspace 1, 6, 19. So what this does is that it gives me 19 evenly spaced values between 1 and 6, both inclusive. So when I run this, I get 19 evenly spaced values between 1 and 6. So I can change these values, and accordingly the output will change. Suppose I give 1, 16 19, so it'll give me 19 evenly spaced values between 1 comma 16. uh, NumPy also has a lot of ways to create random number arrays. Suppose I give np dot random dot rand. So what rand does is it gives me, suppose I give 3, so it gives me three numbers in the range 0 to 1, three random numbers in the range 0 to 1, both inclusive. And if I give 3 comma 3, it will give me a 3 comma 3 array. I can also use np.random.randn, np.random.randn 3 comma 4 suppose. So it gives me a 3 comma 4 array. And randn, what randn does is it returns a sample of values from standard distribution. And if you want integers, you can just give np.random.randint. Suppose 3. So what this does is that I first give a low, suppose 1 comma 3. So low and high value, low is included and high value is not included. So it'll give me one random integer lying between 1 inclusive and 3 not inclusive. So it gives me 2. And if I want like around, suppose I give 1 comma 10 and I want around 6 random values between 1 comma 10, I'll just specify 6 in the bracket. So it gives me 6 random integers between 1 and 10. 10 is not included. So these were the various methods to create random number arrays. If I want to reshape an array, what I'll just do is I'll just give, suppose I want to reshape this into a 2 cross 3 array. So if suppose this is AR equal to, so I can give AR dot reshape, AR dot reshape 2 comma 3. So it gives me a 2 comma 3 array. So I've basically reshaped this array. Apart from that, I can use max min functions to get maximum and minimum values in an array. So suppose my array is RANAR equal to np dot random dot randent 0 comma 25 comma 10. So in this, to get the maximum value, I'll just give RANAR dot max. So it'll give me the maximum value. Similarly, I can give min to get the minimum value, and so 3 is the minimum value and 24 was the maximum value. And to get the argument, that is the index of the maximum value, I'll just give argmax. So you can see that this is at the 24 is at the 7th index, 0, 1, 2, 3, 4, 5, 6, 7. And similarly, I can give argument to get the index of the minimum value. To know the shape of the array, you just need to give ar.shape. So my shape of ar is 2 comma 3. So if I give ar dot shape, okay, no, the shape hadn't changed. So my ar is 6 comma 0. So ar dot shape, if I give of ar dot reshape 2 comma 3 dot shape, then it'll be 2 comma 3. So this is how you can know the shape of your array. And you can also do indexing and selection on your array. So suppose I want to access the third element 8, so I'll just give ar of 2. This is very similar to C++ array, so I'll get 8. So the index is 0, 1, 2 and so on. Apart from that, I can also unconditionally select data in an array. So suppose in this array I want all the data in AR, I want all data that's greater than, suppose that's greater than 5. So what I want to display is 868. So I'll just give AR of AR greater than 5. So I'll get 868. So this is how you can unconditionally select data in an array. Apart from that, now we'll be starting with pandas. So pandas is like hands down one of the best libraries of Python. It supports reading and writing Excel spreadsheets, CSVs, and like whole lot of manipulation. So you can think of pandas like an extremely powerful version of Excel with a lot more features. So in pandas, I'll be talking about series and data frame. So series is basically it's very similar to NumPy array. In fact, it's built on top of NumPy array object. So what differentiates the NumPy array from series is that series can have access labels. It's sort of like a dictionary. So like in dictionary, we have key value pairs. In series, we have indexes for each data value. So basically, it's like a label for each data value, and we can access the data value using that label. I'll show you with an example. So suppose we have a list, labels equal to 10, 20, and 30. And suppose I have a list L1 equal to 10, 20, 30. If I give pd dot series of suppose L1. Oh, okay, fine. I'll have to import pandas first for this. So I get a series with index as 0, 1, 2. This is the default index. So suppose I want to change my index. So this is data equal to L1 and I'll give index equal to labels. Now my index can be anything. It doesn't necessarily have to be numerical data. So now my index becomes this. Also, I don't necessarily need to give data equal to an index equal to if I just give pd.series L1 comma labels, then also it'll give the same output. Now to select data in a series, I can just directly give, suppose this is ser1. So if I give ser1 of, so if I give ser1 of 10, my output will be numerical 10. That is the data corresponding to the 10 label. If I directly pass a dictionary to a pd.series, then also it will give the same output. So suppose I have d1 equal to uh, so this is a dictionary. My keys will become the index in the series and my value will become the value in the series. So if I display my ser1 now, it gives the same output as before. So you can, if I give d1 over here, so it gives the same output. So I can either pass a dictionary over here, or I can give lists, my index and values as lists. And to access a particular index value, I just need to give ser1 of the index name. Uh, this was about series. Now we'll start with data frames. So data frames are, it's directly like inspired by the R language, and you can think of data frame as a bunch of series objects put together, and they share the same index. So data frame looks sort of like a table. I'll show you how a data frame looks. So first I'll import NumPy as np. And suppose I give df equal to pt dot data frame of my data is equal to, I'll just take some random data, np dot random dot random 5 comma 4 will give me a 5 comma 4 matrix having random values, comma index equal to uh, suppose a b c d e dot split, and I'll give my columns as columns equal to w x y z dot split. What the split function does is it splits all the values whenever it encounters a space. So it basically create a list having A, B, C, D, and E as its elements, and this will create a list having W, X, Y, Z as its elements. So whenever it's encountering a space, it's splitting those elements. So if I display df, this is how it looks. So these are the columns having W, X, Y, and Z names, and these are the rows, and these are the index name of the rows. So now for if you want to select a column and display the column, so you can just give df of w, and this will display the column. And if you want to display multiple columns together, you can just give over here comma z in a list form. So it'll give me w comma z. And if I want to if I want to delete a column, I'll just give df dot drop. Suppose I want to drop w column, name of the column, axis equal to 1. So what axis equal to 1 is telling me that I have to drop along the column. If it had been axis equal to 0, then I would have dropped along the row. So if I display this, so my w is now deleted. However, if I display df now, w comes back. So it's not permanent. So to make it permanent, I have to give in place equal to true. So now it becomes permanent. Now if I display df, w is gone now. And similarly, if I want to delete rows, I'll just give axis equal to 0 and name of the row. So I'll give, suppose I want to drop A, I'll give df dot drop A, axis equal to 0. And if I want to make it permanent, I'll give in place equal to true as well. And when I display this, all my rows are there except A. Now, to select columns, what we've done is that we're directly given a list of columns, or for a single column, which is directly written df of w or whatever. So to display rows, what we'll do is we'll use the LOC function. So we'll give df dot, suppose we want to display the uh, row named A, we'll give df dot LOC of A. LOC is label based, so you give the label name over here and it'll display that row. So XYZ displays that row. Now, just like arrays, you can do conditional selection in data frames as well. So suppose I want to display so let me so for this data frame, suppose I want to display all entries having values greater than 0. So I can just give df of df greater than 0. So all the values having that are less than 0, they'll become nan, and I'll be shown only the positive values. My df was this. So all the negative values have become nan, and only the positive values have been shown. So this is how I can do conditional selection. Now, all these NN corresponds to missing data. So, we also have the facility of handling missing data in pandas. So, in order to handle missing data, suppose we consider okay, fine, let's consider a new data frame, df1 equal to pd dot data frame of np. This is the data that I'm giving, random dot random 5 comma 3 index equal to, I can also pass a list over here. Suppose I give A, C, E, F, and H, and my columns are columns equal to, suppose my column names are 1, 2, and 3. 1, 2, 3. So if I display this data frame, this is how my data frame looks. Now if I can change the index values of the data frame by just saying that suppose df2 equal to df1 dot reindex, and I'll give the new index names. So now when I pass the new index names, my df2 has some missing values. So B, D, G rows have missing values. So now to handle these missing data, I I have various functions. So there's a function is na. So what that does is, suppose I give pd dot is na of df2 column 1. So this will tell me that it will return true if value is missing, otherwise it returns false. And if I give not na, it does the opposite of is na. So it's true wherever the value is present or valid, otherwise it's false. So, and if I want to drop the rows or columns containing NaN values, I can give drop na. Uh, so if I give access equal to 1, drop na, access equal to 1, then it'll drop along the rows. So all three rows will get dropped basically because they have NaN values. If I give access equal to 0, it will drop along the row. It will drop along the row. And if I give access equal to 1, it will drop along the column. So all three columns will get dropped. Access equal to 0 will drop B, D, and G because they have NaN values. Sorry, I have to give df2 dot drop na. So all my rows having NaN gets dropped, and I have my data frame having non-NaN values. And if I want to insert missing data with something else, so I can just give df2 dot fill NA, and I'll specify a value equal to suppose data. So now all my places where I had NaN, that gets filled with data. So I can use this to fill values having NaN or missing values. That was about some basic operations. There are other operations like so for this data frame df2, if I give df2 dot head, so this will give me the first 5 rows of the data frame. df2 dot head shows me the first 5. So for large data frames, this is very helpful as it shows the column names, all the column names, and the first 5 entries. And suppose if I give, let me name this as this data frame as df3, and in this is my df3. So in df3, if I give df3, suppose column1 dot unique, then I'll get all the unique values in column 3 get listed out, which are all of them. All of them are unique. And I can also count the number of unique value by giving n unique. That's 5 of them. So these are some basic other operations. And I can also apply a function on a data frame. So let me define a new data frame having integer values. Df equal to pd dot data frame, and I'll pass a dictionary. So to create a data frame, you can also pass a dictionary with keys having the keys will become the columns, column names, and the values will be a list, and that list will become the entries in the data frame. So I'll show you how it's done. So my column1 name is col1, my column2 name is col2, my column3 name is col3, and the data in the data frame will be, it will be passed as a dictionary. Suppose it will be passed as a list 1, 2, 3, 4, and this will be suppose 4, 4, 4, 5, 5, 5, 6, 6, 6, and 4, 4, 4 again. And col3 has some string values like A, B, C, D, F, G, H, I, J, K, L. So when I display my data frame, this is how my data frame looks. So in this data frame, if I want to apply a function, let me define a function df times 2 of x return x bar 2, and if I say df of col1 dot apply times 2. Now what this does is that to each and every entry in the col1, it applies the function times 2 and it returns me the output. So each and every entry is squared in this data frame for the col1. Each and every entry in column 1 is squared and returned as output. I can also sort by values by a particular column in the data frame. Suppose I give df dot sort underscore values by equal to col2. So my col2 is sorted, and according to that data frame is sorted. So it becomes 0, 3, 1, 2. So that was about data frames. Now, we can also input data frames that are stored in the form of other files like CSV files or Excel files. So if I have a suppose CSV file in my laptop, a CSV file is a comma separated values file. So you can, it's basically the CSV data is stored as sort of like Excel sheets only. So if you open it, it looks like an Excel sheet only. It's just the format in which input is given. So the values are given by a comma separated, and that's how uh, it just gets transformed to the Excel sheet. So I already have some CSV files in my laptop, so I can read them into the Python in Jupyter Notebook. So if I give df equal to pd dot read underscore CSV and name of the CSV example.csv, this is already saved in my laptop. So this reads it from my laptop and displays that. You can download CSV files from your from the internet and check this. This you can also read Excel files like this. However, like we'll be using only CSV files. So for now, I'm doing only CSV files. So these were the basic functions that we use in Pandas. After this, we have data visualization libraries like Matplotlib and Seaborn. However, I won't be going into these in detail as there are a bunch of plots like disk plot, joint plot, pair plot, rug plot, KD plot, etc. that these libraries contain, and that will be very time consuming. So you can look up these various plots on the internet, and I'll be moving forward and teaching ML. And in those models, as I use various plots for data visualization, I'll explain it there and then, those plots. So I'll be starting with ML now. So machine learning is basically an automated learning with little or no human intervention. It involves programming computers so that they learn from the available inputs. So basically, we construct algorithms that can learn from previous data and make predictions on new input data. So I'll give you an example for this. Suppose we have a model that predicts the price of a house. We give it various parameters as input, like suppose a house with that has two bedrooms and it's a furnished house with a balcony. It costs around 30,000, suppose. Now, if we change the parameters like four bedroom flat, furnished with balcony, is for 50,000. So now we train our model on this data, we give this as input, and then we expect that when we change the parameters, the model should predict the price of the house. So once I've trained my model with some specific data, so when I change the parameters and then, so suppose I give that, tell me the price of a 2 BHK house that is not furnished and that has a balcony. So I would expect my model to predict some price based on what it has learned from previous data. So this will be an example of machine learning, and it has various applications like fraud detection, web search result, real-time ads on web pages, predicting customer churn, pattern and image recognition, email spam filtering, financial modeling, etc. So machine learning is widely used today, and in order to implement machine learning, you have to follow certain steps. So the first step would be to define your problem. And once you've defined your problem, you have to prepare data. Now, this may involve cleaning your data, removing redundant data, and basically modifying your data such that it's appropriate for your model, and your model gives appropriate results based on based on that data. So you have to modify your data and prepare your data. Then you have to evaluate the algorithm, which algorithm you can apply for your model. So you have a bunch of algorithms with you. You have to choose the one that best suits your need and the one that will best work for your case and give the best results. And once you've done that, you can deploy your model and then you can improve your results. So improving results would be the next step, and then you can present your results. I'll show you how the basic ML procedure works. So once you get the data, you clean the data. This would involve removing redundant data, or if there are entries containing empty data, so you have to modify them. and all those. So once you've cleaned your data, you have to divide it into two parts: test data and training data. Now, training data is the data that's used to train your model. So it's basically the input that's given to the model based on which it learns. And after that, it can predict. Once it has learned on the training data, it's then able to predict based on whatever input you give it. Test data is something that we use to test whether a model is working according to our needs or not before deploying it. So we divide our data into two: test data and training data. With the test data, we test our model. If it's not working to our requirements, as per our requirements, we put it back in the training stage, and we modify our data in the training stage. And once we're satisfied with the output that the test stage has given us, then we can deploy the model. So this is the basic ideology behind ML. So now we'll be moving on to learning. So learning is the process of converting expertise into experience into expertise or knowledge. So it can be divided into supervised learning, unsupervised learning, and reinforcement learning. And they can be further classified as classification, regression, and clustering association. So supervised learning is basically a type of machine learning that enables the model to predict future outcomes after they're trained based on past data. The learning algorithm receives a set of inputs along with corresponding correct outputs, and the algorithm learns by comparing its actual output with correct output to find errors. It then modifies the model accordingly. So, in the training stage, you will give your model the input and you will tell it the output that it should give. And then eventually, you will expect it to give the output based on the input that you're giving it. So in supervised learning, learning data comes with description, labels, targets, or desired outputs, and the objective is to find a general rule that maps inputs to outputs. However, in unsupervised, so I'll give you an example for supervised learning. So suppose you have a email spam detection filter. So what this will do is that it will try to figure out which type of email are being marked as spam and which are not being marked as spam. So based on that, it will use statistical analysis to figure out how likely it is that the email is spam. So if the probability is high, it will label it as spam and the email won't hit your inbox. So basically, it's first checking that which emails we are likely to mark as spam. And once it has learned on that data, then it filters out the emails. So this would be an example for supervised learning. Unsupervised learning is the training of machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without guidance. So here the task of machine is to group unsorted information according to similarities, patterns, and differences without any prior training of data. So the machine is not told the right answer here. We just have raw data and the machine has to make some sense out of the information. So I'll give you an example for this. Suppose we uh, pass various parameters to the machine about information about cats and dogs. Now the machine does not know what is a cat and what is a dog. So suppose we pass various parameters like weight of the dog, weight of the cat, etc. So now, in general, the weight of the dog will be greater than the weight of the cat. So our machine will itself try to group the information such that it will group the higher weight information together and the lower weight information together. So, so what happens is that our machine tries to group the information and make sense out of it. So it's not told the right answer, but it tries to make sense out of the information, out of raw data. So it's divided into clustering and association problem. A clustering problem is where you want to discover the inherent groupings in data, such as grouping customers by purchasing behavior. Another example of this would be that when you're working online, so what type of ads to display to you based on your surfing behavior. So basically, ads that you're more likely to be influenced by. An association would be that. So an association rule learning problem is where you want to discover rules that describe large portions of your data. such as people that buy X also tend to buy Y. So that was about unsupervised learning, and reinforcement learning is basically the algorithm discovers through trial and error that which action yields the greatest rewards, and then it works accordingly. So these are the different types of learning. So now I'll show you how a basic ML model works. So the basic steps involved in an ML model is, first we have to acquire data, clean the data and format it, and then we have to split the clean data into test and training state. And once we have done that, we train our model on the training set and test your model on the test set. And then you iterate your model and tune the parameters of the model until it is ready to deploy. So for this, you'll be using the scikit-learn library. So from sklearn dot linear underscore model or linear regression. So the general format for importing is from sklearn dot family name import model name. So linear regression is the name of the model. I'll be shortly telling you in details what linear regression is. Right now, I'm just telling you the format of the machine learning algorithm, how it's written. So from sklearn dot family name, this is the family name of linear regression model. Import model name. So let me create a model, suppose by the name model. So model equal to linear regression normalize equal to true. So now what this is doing is creating a linear regression model which is named as model, and what normalize equal to true is doing is that so basically suppose as in the previous example, we have various parameters like area of the house and number of bedrooms that decide the price of the house. So area of the price would obviously be a very large value, and number of rooms in the house would be one, two, three, a very small value. So in order to get all the parameters at the same level, so that the output is not like it's not very the uh, parameter having a dominant value is not very the parameter having abundant value is not dominant in the output. So in order to normalize and bring all the data to the same level, we're using normalize equal to true. So once I've created my model, I'll show you how the model looks. So print model. So I've created a linear regression model by the name model. So now what I'll have to do is I'll first take some data. So import numpy as num mp dot train test split. So what this is doing is that train test split is the function that's used to split your data into training set and test set, and you import it from model underscore selection family. So I'll make my own random data. So I'll give x comma y equal to np dot arrange 10 dot reshape 5 comma 2 comma range of 5. So this creating an numpy array from value 0 to 9, and that's getting reshaped into a 5 comma 2 array. So that's getting assigned to x, and range function is giving values from 0 to 4. That's getting assigned to y. So I'll print x and y. This is x and this is y. List of y. So it's having values from 0 to 4. So once I have my data, so now what I'm trying to do in this data is that if I give input 0, 1, my output should be 0. If I give input 2, 3, my output should be 1. So I'm trying to map this input to this output. This is my input data and this is my output data. So if I give input 8, 9, I expect my output to be 4. So now I'm going to divide this data into training and test phase. So to do that, I'll give x underscore train, x underscore test, y underscore train, y underscore test equal to train test split x comma y. This is my data, x comma y, test size equal to 0.3. If I increase the value of test size, so this is basically specifying how much data is used in the testing and how much is used in the training. So if I increase the value of test size, a larger amount of data will be used in testing phase and lesser amount in training phase. So right now I want about 30% of data in the uh, testing phase and about 70% training phase. So I'll display x underscore train. So this is my x underscore train. Corresponding output should be this. So for 8, 4, and for this 2, for the 0, and my x comma test is the remaining values, and this is my y comma test. So right now we've not trained our model, we've just divided data, our raw data, into training and testing. So now that we have divided our data, we'll put the training data into training. We'll train our model based on the training data. So for that we use the fit function. So model.fit x underscore train comma y underscore train. So now we have trained our model, and now it's ready to predict. So predictions equal to model.predict of x underscore test. And if I display predictions, it's 1, 3 as expected. Even my y underscore test was 1, 3. So my model is giving correct predictions. So when my input is x underscore test, that is this, it's giving the correct output. That should be 1, 3. So this is the basic format of how a ML model works, the basic steps involved. So I'll repeat the steps once again. First, we import the model from the model family, and then we create a model variable for that particular model algorithm, linear regression in this case. And we, after that, once we have the data, I've created my own data here. We use train test split to split it into training and testing phase, and we use the training phase to train our model. And once you've trained a model, it's ready to predict. So we use the testing data to test whether it's giving the correct output or not. And in this case, it's giving the correct output. So our model is working fine in this case. So now I'll move on to linear regression, logistic regression, and explain what they actually are. Okay, so I'll start with linear regression. Linear regression is a way of predicting a response y on the basis of single predictable variable x. It can be assumed that there is approximately a linear relation between x and y. So if you look at this diagram, so this is our raw data. It's been randomly distributed. Now in linear regression, my aim would be to draw a line such that it passes through maximum of these points. So I would try to draw a line that passes through maximum of these points, so that if I give a suppose a random x to predict the output, my corresponding y should be such that it's satisfying maximum conditions. So this all will be on my training data. So that's basically what linear regression is. Out of the raw data, I have n number of points. I try to pass my line through maximum number of points and satisfy maximum conditions. And then when I give my input data corresponding to this line, it will give me the output data. So I'll show you a model that's working on linear regression. So I'll first import the necessary libraries. What this command is basically doing is that so that I don't have to type I don't have to type to display the plots again and again. So whenever a plot is created, it'll display it automatically. So that's why I'm using matplotlib inline, and others are just the basic libraries that I need to implement the ML model. So I'll start with taking a dataset that I already have in my laptop as a CSV file. I'll show you the dataset. It's called USA Housing. That's the name I've given it. pd dot read underscore CSV. So you can download a CSV file from the internet for working on your ML model, and I'll display the head of the CSV file of this data frame. So it's a very large data set. I'll show you. So if I give usahousing.info, it shows that there are 5,000 entries in this. So it's a very large data set, and I can use .describe to describe my. So it's basically giving a count being and various parameters that are applied on the data and showing me mathematical output of that. So now my first step after this would be to visualize the data so that I can know what appropriate steps have to be taken uh, in order to manipulate the data. So I'll draw a dist plot for that. Now in this model, what I'm trying to do is that in this model, what I'm trying to do is that I have various parameters, average area income. So it's basically the income of the people living in that area, average house area, age, average number of rooms, average number of bedrooms, population area, population price. So in this model, I'm trying to predict the price of the house based on the various parameters. So if I draw this plot, so this plot is sorry, this plot is basically so it's basically to distribute our data, and I've given the y-axis to see how my prices vary, and I can see that it lies somewhere around 1 to 1.5 million. Average is around somewhere around there. So it's a great way to get started exploring a single variable. So the histogram divides the variables into bins. These lines are known as bins, these lines. And it counts the data points in each bin and shows the bins on the x-axis and the count on the y-axis. So that's what the disk plot is, and so it's basically giving me an idea how the data is distributed. And I can also draw the heat map for this. So if I have SNS dot heat map of USA housing dot CORR, so heat map shows me the relationship that each of the parameters have with itself. So obviously average area income is directly related to average area income. So basically it's a relationship. So as average area income will change, this is the amount that other parameters will depend on this parameter when it changes. So obviously each of the parameters is directly related to each of the parameters, and a not equal true is basically giving me these displaying these values, which it won't display if I give it false, these minus 0.02 and all these values. So what this is showing me that the greater the closer the value is to 1 or minus 1, that means that there's a greater relationship between those particular two values. So my price is very closely related to average area income, how much people are earning in that area. It's 0.64% related. So the color is very easy. So if I see some dark colors, I can see that it's not very closely related. So all these must not be very closely related. And as it's getting light, that means it's more closely related. So this is very closely related. This is very closely related. So uh, heat map is basically showing me the relation, how each parameter is related with each other, and how on varying one parameter, the other parameter, by what amount it will vary. So that's what heat map is telling me. So once I've visualized my data, I can now split it into training and testing phase, and then I can train my model. So let me take the x as so this is the data that I'm taking for my ML model. As previously I had taken a random array. In this I'll take the parameters present in the so these are the column names. So I'll just copy these. Now the ones that will be requiring for training my data. So the input will be average area income. I'll require that. Average area house age. I'll require that as well. Average area number of bedrooms. I'll require that as well. Average area number of bedrooms. Yes. Area population. Price is the thing that we have to predict. So that will be Y. That won't be X. And address is not useful to predict the price of the house. So I'll remove address. So my output should be the price of the house. So my Y will be USA housing price. So now my what goes into my X is the parameters that I want, depending on which my Y will vary and my model should predict Y. So these are the parameters and this is the output that I want. So now I have my data. Now I can directly train test split it. So from sklearn dot model underscore selection import train test split. And now after that I'll again do the same thing that I did above. So I'm splitting it, and I'll take test size equal to zero point 0.4, and random state equal to 101. So this is basically fixing my data values, because every time I run this command, my training and testing phase will be randomly picked. So it will be different every time. However, if I specify a random state, each time then the training and testing data will be the same each time I run this command. So when I run this, now once I've done this, so let me import linear regression model from sklearn dot linear underscore model, import linear regression, and let me name my model LM, linear model, equal to linear regression, and LM dot fit X train and Y train. So now we've trained our model, and to evaluate how closely or how perfectly our model will predict the output, we can check that using a graph. So suppose I draw a graph of our predictions versus our actual Y test. So let me draw a scatter plot. So predictions equal to lm dot predict x underscore test, and plt dot, so scatter plot comes in matplotlib, so plt dot scatter. I'm plotting y underscore test on the x-axis, predictions on the y-axis, and edge color equal to black. So now, if my y underscore test and predictions were to be same, so it would give a y equal to x graph. That would be a straight line. We can see more or less our graph is giving a straight line. So our model has given a pretty good response, because more or less this is a straight line. We can never get 100% perfection in a model that has large number of data. But in this case, our model is giving more or less a straight line, y equal to x lines. So we've done a pretty good job in uh, changing our information accordingly, and evaluating the and making training our model. So you can also visualize this using histogram. So if I plot a histogram, sns dot distplot of y underscore test minus predictions, then I can see that my result averages around zero. So there's not much difference between y test and predictions. So since my result is averaging around zero, so that means I've done a pretty good job in the model. So that was about linear regression. Now I'll move on to logistic regression. So logistic regression is one of the basic and most popular algorithms to solve a classification problem. So the underlying technique is quite same as linear regression, except that in linear regression we were trying to predict basically the price of the house, some sort of information. But in logistic regression, it's a classification problem. So we will classify it. So something like email, is it spam or not spam? Or transaction, is it a fraudulent transaction or not fraudulent transaction? Or is the cancer tumor malignant or benign? So we'll be classifying. So it's a classification problem. So we use classification problem when independent variables are continuous in nature and dependent variables in categorical form. That is in classes like positive class and negative class. So there can be more than two classes also in which it's classified, and those are multi-class classification problems. So why don't we use linear regression in this case? So suppose we're trying to classify a tumor into malignant or benign, and one means that it's malignant and zero means it's benign. So suppose this is how our data is distributed, and if we draw a straight line through it, we can see that if we suppose take threshold as zero point 0.5 and correspond to that value, if we take this as the negative class and this as the positive class, so all these values will become 1 and all these will become 0. So in this case, if we see, then there may be some outlying values, because if there are values lying towards this side of the line that we are drawing, so there may be cancer cells that are actually malignant, but we may classify them as benign. So we can do a better job if we use logistic regression. So in logistic regression, we use the sigmoid function. So we can do a better job of classification in this case. So this is the comparison between both. In sigmoid function, that is fx equal to 1 divided by 1 plus e to the power minus x, we do a better job in classifying yes or no algorithms. So let me show you an example of logistic regression model, and I'll also implement data cleaning in this. So I've imported all the necessary libraries. I'll read a CSV file, train equal to pd dot read underscore CSV, Titanic train dot CSV, train dot head. So this is my CSV file. I'll just show you basic information about this. Dot info. So it has 891 non-null columns, and so you can see that this is 714 not null columns. That means 891 minus 714, there are null values in this data set, and this contains mostly, this k-bin column contains mostly not null mostly null values. So this will be a problem in our data set. So we have to modify this so that in this case we have to clean our data set. We have to clean our data frame. So there are various methods to clean the data set and data frame. So in this case, let's start with making so if I display head, now we've seen that in the age class there are some missing values. So what we could do is that either we can take an average of all the age values and we can put it in those NaN places. However, we can do an even better job if we make a box plot and visualize the data. So I'll draw the box plot for age. So plt dot figure, fig size equal to. So this is basically making a background canvas for me on which I'll plot the box plot. SNS dot box plot. My x will be p class, y equal to age, data equal to train, and palette is for the color. So I'll give winter. Now the reason I've done this is that on the basis of P class, I have distributed my age. So I can see that in the first class, so this is the passenger class, first class, second class, third class, And in this data set, this is 01 survived. This is telling whether in the Titanic crash, whether the passenger survived or not. This is the passenger ID, name, sex, age, and SIB-SP is sibling or spouse present, number of sibling spouse present. PRCH is parent child present, ticket, fare, cabin, and embarked is from the place where it embarked. So there are three values in this, S, C, and Q, all depicting the names of the initials of the place from which it embarked. So in this, I can see that people in the first class tend to have a greater tend are older than people who are in second or third class. So this also makes sense because maybe the people in first class have taken time to accumulate money, so they're maybe older than people in second class. So you can see that in the first class, the age averages to around 37. In the second class, the age averages to around 29. And in the third class, the age averages to around 24. So that means that instead of taking average of the entire data set and putting it in the NAN, we can put different averages for different class. So for missing values in first class, we'll take the average of all first class ages and put that in the average. Put that instead of NAN. So we'll be doing a better job that way. So for doing that, we'll make a function. So I'll define a function def impute underscore age calls age equal to call 0, p class equal to calls 1 if if the uh, value is NaN, so then I want to replace it with average of that particular class. If period is null age, then if p class equal to 1, return 37, because I can see that the average age is around 37. Elif p class equal to 2, then return 29, else return around 24, and after this else return the age. So if it's not a null, then return the age as it was. Now this is my function, so I'll apply this on the data set. Train age equal to train age comma p class dot apply impute underscore age comma axis equal to 1. So now what I'm doing is that this is how you apply functions to for particular columns of a data frame. So to train age comma p class, I'm applying the impute underscore age function along the column axis equal to 1. So that's done. What I'll do is I'll show you the typed version of this. So this is the box plot that we had drawn, and then this is the function, and I apply the function on that, and I make a heat map now to check whether how many values are missing. So this yellow is indicating missing values, and purple is indicating filled values. So now after applying the impute age function, I have filled all my age values. So this is completely filled now. All others didn't have any NaN values. We can see that Kbin has a lot of NaN values. So how I've drawn the heat map is I've given train dot is null. What ytick labels is equal to false does is, so it will list out each and every entry in the data frame. So it'll create very chaotic over here. So I don't want that to happen. And c bar equal to false is it'll create a color bar over here telling me that yellow is for entries that are not present, and purple is for entries that are present in the data frame. And cmap equal to what is basically for color. So this heat map is telling me that in Kbin, majority of the entries are not present, are NaN. So I can directly drop the Kbin row column as it won't affect my data frame much. So I'll directly drop my column. So train dot drop Kbin axis equal to 1 along the column, and it has to be permanent. In place equal to true. So now if I show you the data frame, this is how my data frame looks. Train dot drop Kbin. Okay, Kbin has been dropped. So I'll remove this. So as you can see that Kbin has been dropped now, and this is how my data frame looks. So I also had seen that I had a few entries in Embark that were having NaN values. So I'll directly drop those NaN values. So for that I'll give train dot drop NA in place equal to true. So this will drop all rows having NaN values. Once I've done this, if I want to see the heat map again, it will now be completely purple as all the values have been filled. So now I can employ my model and test and train it. So there's one more problem with the data frame. So if we see that train.head, in this data frame, our sex is in the form of string, male and female. So the computer won't be able to understand that. So we have to make it in the form of 1 and 0. So to do that, we use a get underscore dummies function. So that's what we've used here. After this, I'll do dot get underscore dummies. So what this is going to do is that it's going to create dummy values for the column having the name sex. So male or female will be randomly given values 0 or 1. However, what I want to do is that uh, I'll show you what output this gives. So it's having two columns, male and female. So I just need one, so I'll drop one of them. I'll just say drop first equal to true. So now I have this male 1010, and that I can attach to my data frame now instead of these strings. And similar thing I can do with the embarked column, as it had SC and Q. So I'll make it again into get dummies. So I'll type embark equal to pt.get dummies train embarked, drop first equal to true, and then I'll show embark.head. And so basically I have Q and S. It's divided that into that. We had three values in embarked, S, Q, and C. So it's given the labels accordingly, and now we can attach this to our data frame instead of SC and SC and C, so that our computer can understand that. So we'll add these values to the data frame. We do that using the concat function. So we'll create a new data frame, train equal to pd dot concat the previous train dataset, sex dataset that we've created now, and the embark dataset that we've created now along the column. So axis equal to 1. And now if I show train.head, you can see that now we have, okay, so I attached it earlier only. So I've attached this twice, so leave this for now. So now you can see that we have male as well and sex. So we need to drop this sex and we need to drop this embarked. I'll rerun the code once. Uh, Not box plot. Now you can see that we have male as well as sex. So we need to drop this sex. We need to drop this. We need to drop this embarked, as we have made embarked already. So, and since we need to predict whether survived or not, so we can drop the survived as well. So after this, I'll just say train dot drop the sex column, the embarked column, and the ticket column will also not be useful for me to predict the whether passenger survived or not, and the name won't be useful. The passenger ID won't be useful. So I'll drop name as well, and passenger ID. I'll drop all these. Axis equal to 1 because along the column, in place equal to true. So now if you see the train head, we're left with the data frame that we wanted. So we've refined our data and modified it according to what we needed. We'll also drop survived because okay, I'll first create a x equal to train dot drop survived access equal to 1, and I'll show you what X looks like. So this has already been executed, so I'll comment this out. So this is how our inputs look like now, and I'll also need to create y, the output, that is whether survived or not. So y equal to train of survived, and I'll show you y dot head. So it's just output 0 or 1 whether it survived or not. So now I need to train test split my model. So again, as the previous step, we'll first import from sklearn dot model selection, import train test split, and then I'll classify into training test and splitting data, training and test data. I'll take this 0.3 and random state equal to 101. So once I've done that, my data has been split. So now I need to predict. So to predict in this case, I'll have to first import the model. So from sklearn dot linear underscore model, the family name, import the model logistic regression, and let the name be lm equal to logistic regression, and lm dot fit x train and y train, just like how we did previously. And once I do this, my model has been trained. Once my model has been trained, now I can predict. So suppose predictions equal to lm dot predict on x test. So my predictions are now ready. To check if I've predicted correctly or not, I can use something known as classification report. So we have a separate function for that from sklearn dot matrix import classification report and print classification underscore report y underscore test comma predictions. So you can see that we got a precision of around 80% in our predictions, so that's pretty good. and recall, F1 score, and support are other parameters that indicate the same. So they basically used to tell how well our model has performed. So this was for logistic regression, and these were the two algorithms that I was doing today. So if I hope you had something to take away from this webinar today, and at least you understood something out of this webinar. Thank you.